Welcome to my video. Now in today's video, we'll be looking at simplifying algebraic expressions by collecting like terms. Please, if you've not subscribed to my YouTube channel, kindly subscribe. So we start off by looking at what like terms are. Like terms are terms with the same variables and the same powers. So let's say, for example, you have this expression 5y plus 2x plus y. And looking at the definition given, it says the same variable, terms with the same variables and the same powers. So in this expression, we have three terms. The first term is this, the second term is that, and the third term is that. Now, when we look at the first term and compare that with the second term, we can see that they do not have the same variable. This one has the variable y, this one has variable x. So the two are not like terms. And when we look at the third term, the third term has variable y. So the first term and the third term are like terms. So we are going to have 5y plus y, and this will give us 6y. So the answer to this is going to be 6y plus 2x. So we've simplified this expression to give us that. Now let's look at some examples. So in the first example, we are asked to simplify, and we can see that in this expression, each term has the variable f to the power of 1. Now, anytime you see a variable without any number on top, so for example, p, without any number up here, it tells you that the power of the variable is 1. So p is the same as p to the power of 1. But in mathematics, we make the 1 invisible. So we write it as p instead of p to the power of 1. So this one, this term, this term, this term, this term are like terms because the variable in each term are the same and they have the same power. So we are going to have 1f. Now the coefficient of the first term is 1. So we have 1f plus 2f, which will give us 3f plus 4f, 7f, and then plus 1f. So the answer to this is going to be 8f. In the second example, we have 3f to the power of 1, 5f to the power of 1. Now, both variables are the same and the same power. So the 3f and 5f are like terms, and this will give us 8f. Now, the 2 doesn't have f multiplying it. So the 2 and the rest are not like terms. So we are going to have 8f plus 2. In this example, when we take the first one, we have 5g squared. Now, they all have the same variables, but the powers are not the same. So the first term and then the second term are not like terms because the power of g for the first term is 2 and the power of g for the second term is 1. And since they are not the same, they are not like terms. We move on to the third term, which is 2. Now, 2 doesn't have any variable multiplying it. So the first term and the third term are not like terms. And the same thing applies to the fourth term. The power of the variable g is 2 in the first term. This is 1. So the fourth term and then the first term are not like terms. When we come to the fifth term of this expression, the variable there is g and the power is 2. So these two are like terms. And always check the sign in front of each term. So we are going to have 5g squared minus 2g squared, and this will give us 3g squared. Now let's look at the other like terms. If you look at the second term of the expression and the fourth term of the expression, you can see that these two are like terms because we have g to the power of 1 and the fourth term also has g to the power of 1. So we have 6g and then minus 9g to be like terms. So we are going to have 6g minus 9g, and this will give us minus 3g because 6 minus 9 is negative 3. So the answer to this expression, when we simplify this, is going to give us 3g squared minus 3g. Now we'll be left with the 2. So we add the 2 to it plus 2. So we have simplified this expression by grouping like terms. In the next example, when we take the first term and compare it with the second term, now the first term has the variable n squared, the second term has m, so the two are not the same. And when we check the first term with the third term, now the power of the first term, which is n, is 2, and the second term, the power of n is 1. So the first term and the third term are not like terms. When we come to the fourth term, the power of n is 2. So we have the first term and the fourth term to be like terms. So we are going to have minus 7n squared plus n squared, which will give us minus 6n squared. Negative 7 plus 1 will give us negative 6. Now, when you check the rest, we do not have any other like terms in the expression. So our answer to this is going to be minus 6n squared minus m plus 16n plus 12. So we have simplified this by collecting like terms. We can also have terms with more than one variable. So for you to have a like term, you must make sure that the terms have the same variable and the same powers. So let's look at this example. In this example, we have 3a squared b. When we compare that with the second term doesn't have a squared. So the first term and then the second term are not like terms. Now, one thing we have to note is that for a squared, b is the same as a squared times b. And multiplication is commutative. So we can write this as b times a squared, which is the same as ba squared. So it tells us that this first term and the third term are like terms because they have the same variable with the same powers. So we have 3a squared b and then the 4ba squared to be like terms. So this will give us 3 a squared b plus 4ba squared, which is 7a squared b. These two are like terms. And then we look at the second term and the fourth term. Now, AB is the same as A times B, which is B times A. And this is the same as BA. So the second term and the fourth term are like terms. So we are going to have minus 2ab. Always check the sign in front of the term, minus ba. And this will give us minus 3ab. So the answer to the question above is going to be, so 3a squared b minus 2ab plus 4ba squared minus ba is equal to 7a squared b minus 3ab. So that is the answer. We have simplified the expression by collecting like terms. Please pause the video and have a go. So in this question, if we pick the first one, in the first expression, if we compare the first term with the second term, these two are not like terms because the power of x here is 1 and the power of this is x squared. They are not like terms. So we look at the third term. Now the third term, we do not have it. So the third term is also not a like term. We move on to the fourth term. Now in the fourth term, we have variables x squared y, which is the same as x squared y in the first term. So we are going to have these two to be like terms. So we have 3x squared y plus 2x squared y, and this will give us 5x squared y. Let's see if we have other like terms. So we come to the second term. We have xy and we have xy in the fourth term. So so the second term and the fifth term are like terms. So we are going to have minus 2xy plus xy, and this will give us minus xy. This is the same as minus 2 plus 1, and the answer is minus 1, which is minus xy. So the answer to this expression, after we've simplified it, is going to be 5x squared y minus xy. Now we are left with this one, so we add it to the answer, which is 7xy squared. In the last example, we have the first term and the second term are not the same. This is a to the power of 1, b squared. Here is a squared, b to the power of 1. They are not the same. The third term, if we compare that with the first term, they are not like terms. But when we look at the fourth term, we have a squared b, we have a squared b in the fourth term. So we have a squared, these two are like terms. So we are going to have a squared b minus 7a squared b, and this will give us minus 6a squared b. This is the same as 1, the coefficient 1 minus 7, which is minus 6. So we'll have minus 6a squared b. And the rest, we do not have any like terms. So the answer to this will be, minus 6a squared b plus 2ab squared plus 8ab. So this brings us to the end of this video. Thank you for watching, and see you in my next video.